Did Dom just drop the ICP video of the year? Today, guys, we're going to be reacting to the new video that Dom just dropped, and it's a big one. It's one that they've been teasing for a while on the DFINITY Twitter, and I have not seen this video yet, actually. I saw this, it just released, and I decided, why not just do a live reaction, get some content out of it as well. So we're going to hop straight into it. As you can see, 5 hours ago, Dom tweeted out AI times ICP times internet times everyone, self-writing internet. And yeah, so we're going to see what this is all about. You can see it already has 1.2K likes. And yeah, let's do this.
Hello everyone, and welcome to 2025. This is the year that the decentralized internet ecosystem and AI gets real. So last year we already saw the internet computer begin to host AI models in the mode of smart contracts, including large language models. And during 2025, we're going to see further increases in performance and in the number of parameters that these models can use. But today we're going to be talking about the self-writing internet. This is a completely new paradigm where anyone, anywhere in the world can interact with network intelligence using natural language to build out their own sovereign corner of the internet ecosystem. This new self-writing internet paradigm is going to be tremendously impactful and ultimately change the way tech works. And I believe in 10 years, as a result of the self-writing internet, many things will be completely unrecognizable. Okay, so let's get started. The title of the talk today is Where AI Builds. So let's begin by considering what we're going to see tomorrow. And I can promise you this tomorrow is not far.
Those are some pretty bold statements right there, saying it's going to change, the internet and everything. So excited to see where this goes.
Away. So we're going to be chatting with AI to create running web applications and internet services. This is an inclusive, broad paradigm that empowers everyone. An individual might want to create a personal branding website where they can make blog posts, share photographs, share files maybe, or maybe they want to create a game to share with friends or a web application for planning and organizing their wedding. An entrepreneur or small business owner might want to create an e-commerce website or a sharing economy service with Web3 Rails, say. A corporation or government department might want to create a corporate portal or CRM or ERP functionality, which they will otherwise have to obtain by signing up for some incredibly expensive SaaS service where they become locked in, their data gets stuck, and they still had to spend a lot of money on consultants customizing the functionality. Of course, this new self-writing internet paradigm isn't just about the initial act of creation. You're going to start out by chatting to the AI. It's going to return a URL to you, which you're going to click on, and it's going to open your browser showing the web application or internet service that you created. But of course, you're going to want to improve that continuously by chat, both initially and over time. And the paradigm will allow you to do that. You'll simply talk to the AI and refresh your browser to see the changes. Even when you're updating an internet service that might have hundreds of users and there's a ton of data inside that you can't risk losing. So this is a completely new paradigm where we simply describe to create and build out the internet ecosystem in ways that we want. But this new paradigm has been enabled by the confluence of two other paradigms. On the one hand, we have...
So basically, from what I'm hearing, and for some, just background on this, of course I know, Caffeine AI is the main thing. That's DFINITY's product they're going to be coming out with. I know about it, etc. I'm not super deep into it, so there's a lot of, and I guess some questions I would have are, and some things I think people are wondering in general is probably, what is the level of application you're going to be able to get out of this? Now, of course, the Caffeine AI product will improve over time, etc. But is this just going to be something where you're able to spin up some really small website, Wix-like, Or is it going to be something where you could, spin up sort of a bigger application? I guess nobody knows except the people who are making caffeine AI. And I assume, 10 years from now, 5 years from now, it's going to be looking a lot different. But I guess in this next year, what is it going to be looking like for this bull market is, kind of a big deal because, you know, we need to make the most out of the bull market. So I guess that's kind of the one things I'm wondering. And then another thing I'm wondering is, what are the big, we saw Pump Fund. They came out with their own product as well. If you didn't see that, Pump Fund came out with a something that seems similar to caffeine, where you're basically able to talk and it makes an application. And Pump Fund's huge in the space and massive. So what is the edge of the competitor going to be? Like seriously, what is the edge of the competitor going to be for the normal user? Not talking about corporations, government, etc. I'm talking about everyday users. How is caffeine AI going to defeat its opponents? Because there's a bunch. It's not. I'm sure there's a bunch of other companies that are trying to do this as well. So that's kind of another question I have is how are they going to be able to win over the user? So if it's that much better than the other products, that could be reason why. But we'll see, I guess. I mean, hasn't released, so. But these are just some of my thoughts I'm having.
Super advanced large language models capable of writing highly sophisticated code. On the other hand, we have the internet computer, a compute network that's been optimized for AI and has properties that allows it to build solo in a safe way. And the result of that is that we can produce applications like caffeine, which allow us to interact.
Because I'll tell you just, and I don't want to, keep pausing or whatever, but from my personal beliefs is that the user does not care about security that much. They really don't. And that's where I'm kind of wondering is how is caffeine going to be able to win over the user? Because if you're saying it's fully on chain, user doesn't care. If you're going to say it's secure because it's in a canister smart contract, user doesn't care. So that's where I'm kind of interested to see, what's going to happen now. These are just more of my thoughts, of course. And, I am someone I'm always trying to look to be critical on everything because I'm an investor. And I think if you're an investor, you should be, trying to be critical because you're invested. So, yeah.
With AI to simply create web applications and internet services through describing what we want. So now we've taken a peek at the future. Let's rewind a little bit and review some of the challenges we'd face if we tried to implement the self-writing internet paradigm using traditional IT. So I'll start off by considering the complexity of current IT in the traditional tech stack. So the easiest way to convince yourself that it has unbounded nuance and detail is just to have a look at the sheer volume of technical documentation that exists. It stretches into the hundreds of millions of pages. And this complexity is the reason that IT personnel today spend 95% of their time chasing complexity, focusing on how they build rather than what they build. And it turns out this is not an ideal stack for AI that wants to write code and upgrade running systems in one shot. The next big problem I want to talk about is cyber security. Current IT depends on protection by fallible cybersecurity tech. That means that we use things like firewalls to prevent hackers getting inside our infrastructure and infecting it. But one configuration error, one software patch with malware hiding inside, and ransomware and data exfiltration attacks can succeed. That means we can lose both our systems and our data. Unfortunately, this is an unfixable situation. Current IT involves a paradigm where a stack of software runs directly on silicon. And as it turns out, there is no way to get firm security guarantees with this architecture. So to summarize, there are quite a few problems with having AI building solo on current IT. Firstly, a hack is one hallucination or mistake away. And we have to assume that even the most advanced large language models will make mistakes and suffer hallucinations. So that's really a showstopper. It can't possibly be the situation that we talk to an AI and it updates our web application or internet service in a way that results in it getting hacked. But there are also other major problems which are more subtle. For example, current IT.
So my thoughts on that is obviously like if the hack, that would be horrible press for whoever, but I do think if it's like a hack it's a very rare hack. I don't know if people would care that much. I mean, once again, corporation government would care a lot, of course, but would users care? I'll give you an example of like Phantom Wallet. So Phantom Wallet's the most popular wallet in crypto. It's amazing. And there's a drain that happens. I'm sure everyone here knows what getting drained is. And I've heard of people getting drained on Phantom before, but everyone still uses it every day, and it's still the most popular. So despite there being multiple occurrences of people getting drained on Phantom, people still use it every day because it's a superior product. So I think, in my personal opinion, if Caffeine AI is able to have a great user experience and great onboarding experience and work really well and be user friendly, and it has the security component to it, that's great. But it needs to have both. And of course, we'll see.
IT isn't designed to allow web applications and internet services to be upgraded at chat speed. And in addition to that, errors that occur in migration logic can result in data being lost. And that again is a showstopper. Imagine creating a user forum which is used by hundreds of thousands of people and then talking to the AI to add some new features, and then all of these old forum posts disappear. That can't happen. Another issue is that current IT installs and admin can be incredibly slow and involve problem ladders, which we've all experienced ourselves in different ways. It might be necessary to upgrade the database on current IT, and then you find that it needs a new library, but the new library only...
And I could be wrong, but on the second point, once again, I could be wrong. I'm pretty sure that one of the unique things about the internet computer, once again, I could be wrong, is that, the canister smart contracts, they're upgradable and you don't have to deploy a new contract. Like an example for like Ethereum, you always have to deploy a new contract if you kind of want to make a major upgrade. An example of this would be like Uniswap. So Uniswap, they have Uniswap V1, V2, V3, V4. And every time Uniswap had to do a major upgrade, they had to redeploy new smart contracts in order to make it happen. With the internet computer, with the current canister smart contract, at least to my knowledge, once again, could be wrong, it's easily upgradable, and, you don't have the same problems that Ethereum would have, or I guess current IT also. Of course, current IT is not using smart contracts, but I kind of just want to make that point with canister smart contracts.
It comes with the next version of the operating system, and so on. That's not a chat speed operation. And similarly, current IT is incredibly complex. So when you upgrade something like a web application or internet service, there are lots of different components that have to be upgraded in a synchronized way. And that's time consuming as well as complex. And it doesn't happen at chat speed. So now we understand the problems involved with having AI build solo on current IT. Let's move on to how Internet Computer Protocol, ICP, makes it possible. So this is the Internet Computer Network's dashboard. It's a big network that is hosted on sovereign hardware run by more than 130 node providing organizations around the world. Internet Computer Protocol in the public setting creates a permissionless world computer where you can just upload to create and update web applications and internet services. And currently there are already thousands running, but we believe the self-writing internet paradigm will quickly drive that up into the millions. So ICP addresses tech fragility. This is incredibly important because complex traditional IT is impossible to make reliable, and even its foundations are highly vulnerable. It's built in a centralized way from numerous platform components, and the resulting complexity is a key source of the lack of reliability. It's also vulnerable to cyber attacks, and in the future, things like state sabotage. And the problems are in plain sight. This summer, a patch was applied to the CrowdStrike platform software system, and it caused 8.5 million systems to crash and prevented their restart. Back in the day during COVID, an Amazon Web Services data center outage caused the New York subway to stop working. This is a lot for one-shot AI to deal with. The good news is ICP goes much further than fixing fragility. It creates a revolutionary compute stack that is immune to normal cyber attacks, a new kind of unstoppable compute stack that...
I'll say the one thing for the cyber attack thingy is, of course, you know, that's what it is. But I think one of the big things we're going to see with ICP, if we see it, is it being battle tested. Like AWS has, they're huge. You know, it's made by Amazon, a multi-trillion-dollar corporation. AWS is a major cloud hosting platform. They have all the market share basically. And ICP is not as battle tested as AWS because, you know, once again, you could say, like the examples he was making are real and everything. But once again, there's a lot more people trying to hack AWS than ICP, and it's not even close. So ICP is not battle tested to the degree of AWS. And I'm not saying ICP would be hacked, but I'm just saying it has not gone through the same level of, you know, battle that AWS has, which we'll see over the next decade what happens and everything. Yeah.
Is ideal for one-shot AI. Compute is replicated across distributed hardware using a mathematically secure network protocol within which is hosted a virtual execution environment that holds a cloud computing environment. This is a revolutionary approach that is a departure from the paradigm of current IT, where you have a stack of software running directly on the silicon. This mathematical network protocol has a property known as Byzantine fault tolerance. This means that even if an attacker gains physical control over some of the hardware involved, although that might enable them to steal data, it will not enable them under any circumstances to break the network or corrupt data of any of the web applications or internet services that it hosts. This is the beginning of a compute revolution, and it's also the perfect platform for AI to build on. In this revolutionary new internet compute stack, the complexities relating to failover and cybersecurity are gone. You just upload serverless code and go. And this serverless code is highly abstracted logic, but it's all that you need to create and update apps. So AI can code, upload the code to the internet computer, and then a couple of minutes later, max, the new experience can materialize. And these apps and internet services are tamper-proof, so there's no need for the AI to manage cybersecurity measures. And they're unstoppable, so there's no need for the AI to measure failover and backup. ICP goes further still. It introduces a new compute paradigm called orthogonal persistence that really reimagines compute itself. With this paradigm, data and logic are very much the same. When only abstract logic remains, then we define what rather than chasing how, and this is ideal for AI. On the internet computer and on any other ICP platform, there are no files, there are no databases, just unstoppable logic. And this is why we say that data persists orthogonally. Now, take a look at this simple code here that defines a blog. Here's a data type defining a post. It has a title and a body. Below that is a declaration of an array of posts. This declaration is all that's necessary to have the blog maintain its list of posts. Now, compare that to traditional IT, where in order to persist the blog posts, you'd have to marshal them in and out of a database server. This is quite literally orders of magnitude more simple. And this again is very good for one-shot AI. Now we get to some of the real secret sauce that allows AI to build solo on internet computer protocol stacks. AI needs to update apps at chat speed, and ICP makes this possible by allowing code to efficiently morph memory during upgrades. But there's more. Domain-specific languages like Motoko, which are optimized for AI, leverage ICP features to ensure that during these data migrations, during upgrades, no data can be lost. It's called loss-safe data migration. So rewinding to our example, here's our initial definition of a blog post. It's just a title and a body. But we want to update this so that a blog post also maintains a count of the number of likes. So the AI would actually upgrade this blog in two passes. In the first pass, it would update the original definition of a blog post to add the likes field. In the second pass, it would write a migration file describing the logic that would update the old format blog posts into the new format blog posts. Now, what's super cool is that this will not compile or install on the network if it would result in data loss. And in fact, the updated code would be checked against the currently deployed code to make sure it's just not possible for something to get lost. And hopefully from these last few slides, you're getting a sense of what I was talking about at the start of this presentation about the confluence of advanced large language models that can write code with compute platforms that are designed to enable AI to build solo. Okay, so where does this take us? In the future, the self-writing internet paradigm will enable us to create web applications and internet services at tiny cost and with massive speed. Here I suggested 1% of the cost and 100x speed up. This sounds extreme, but I can tell you, in my own experiences with this technology so far, I think it's realistic. And these applications will be scalable, efficient, interoperable. They'll support Web3. You'll be able to create new AI from AI. And of course, it'll all be decentralized and sovereign.
Caffeine AI from Caffeine AI?
This is the new paradigm, and this is what I believe is going to change tech forever. And now we're going to talk about the elephant in the room, which a lot of people have expressed concern about. What does the self-writing internet paradigm mean for the millions of software engineers and designers around the world? Well, I believe that it's going to result in more growth and more employment. First of all, the self-writing internet paradigm will empower 8 billion non-technical people to create web applications and internet services. Some of those, of course, will enter roles in tech, become prompt engineers. Some of them will even become tech entrepreneurs, and others will join new online communities. As the result of their activities, we are going to see millions and millions of new web applications and internet services being created. And inevitably, some of their owners will require professional human assistance. And that will mean, in my view, more work for software engineers, user experience designers, and growth hackers.
So my kind of take on this, as someone who's part of the non-technical group, is what, because it's saying some enter roles in tech. And obviously, once again, I said at the beginning of this video, but this technology is going to evolve over, years, etc. But my personal thesis is that the senior level developers are not going to be replaced. I think it's going to be like if you're trying to do, basic code and maybe at some point, like junior level engineering type stuff, then you can get away with it. Most of coding, like I've done a little bit of coding, nothing serious, taken a couple of Python courses, copy and pasted and, did some things on Binance Smart Chain last cycle. Not much so. Nothing to say I'm a technical person. But what I personally believe is right now, at least at launch, what I'm expecting, or at least what I think is it's going to be something where it can do basic code and do kind of basic functionality, which is okay because, the technology is going to evolve. But I don't see senior level engineers getting replaced anytime soon. I don't see that. So when it says 8 billion non-technical people empowered, I guess it really depends on how, complex of an app can you make with this tool. And then of course, I don't think it's going to empower 8 billion people to be at the same level as a senior level engineer. And then for the millions of new custom apps and services, once again, we're just going to have to see it in action and everything. So Yeah, very exciting though. I mean, I'm definitely going to play around with it and see what I can do once it comes out. I'll make videos on it, of course.
So the future is bright and it involves the self-writing internet paradigm and internet computer protocol, the most sophisticated network protocol ever engineered by a mile. Democratize, decentralize with advanced technology. I work for the DFINITY Foundation, which is designed as a NASA for decentralization, and we bootstrapped ICP technology through more than 1,000 person years of R&D effort. Our mission is to make compute secure and unstoppable and enable AI. So thank you for listening. If you'd like to get more updates from me, follow me on X and feel free to get in touch with the foundation. Thanks again.
Yeah, so if you want to follow Dom, it's just Dominic_W on Twitter. You can search up Dom ICP. And if you want to follow DFINITY, it's just at DFINITY on Twitter. But yeah, I think that was a good video. I like the new style of doing the the video and him showing around everything and all that stuff. I think it was good. I think it was pretty simple to understand. I think he kind of got the gist across. It's just, we're going to have to see what happens when it actually gets deployed. That's kind of the big thing. I mean, talk is cheap, so it's going to be interesting to see what happens when it actually gets deployed. I'm expecting, hopefully, it ends up being a success. And of course, I'm not expecting it to do absolutely crazy things off the bat. It's going to be something that's going to evolve and hopefully be a big thing. Hopefully it can be a big thing right off the bat. I'm hoping, wanting the ICP price to go up and everything. So yeah, we'll see what happens. And if you enjoyed this reaction, enjoyed this video and hanging out with me and everything, make sure to subscribe, leave a like, leave a comment, follow me on whatever platform you're watching me on. And yeah, more content coming soon. And thank you for watching.